Hello, pre-IB students. This is Miss Kiely. Welcome to Wednesday digital learning class, I guess. Thank you for your submissions on Google Classroom. Please remember that I will be looking at the timestamps. So if it wasn't submitted by 9 a.m., 3/18, March 18th, Wednesday, then it will not be accepted and it will be a Z, okay? Please take your time to do these assignments with ample time before the deadline. And reach me at my email, eliza.kiely@gmail.com if you need anything. What we're going to be doing today is looking at the answers to your assignment 1 through 8 and going through them, making sure that you solve them correctly. And then I will be giving you your assignment that it will be due on Friday via Google Classroom. So look out for that, okay? Number 1, we're going to start with P. P, I already know, goes in the center because H has to go on the sides. So P, being in group 15, is going to have 5 valence electrons. Notice I put all 4 on each side of P first. Then I go ahead and put the last one. And now I'm going to put the H's. Perfect. And I can leave H like this, or I can bond like that. And basically what I realize is I have 3 single bonds. There are 3 single bonds holding this structure together. A single bond is a bond where you have 2 electrons being shared between 2 atoms. So here's a single, and here's a single. All right, awesome. Let's look at number 2, carbon dioxide. So for carbon dioxide, I don't even have to look at the difference in electronegativity. I already know carbon goes in the middle. Carbon is always in the middle because it's in group 14 and has 4 valence electrons. That means that it has the ability to make a lot of different bonds on every side of it. That is why it is always in the middle. Oxygen is in group 16. That means it has 6 valence electrons. I'm going to put each oxygen on each side of the molecule. And I'm going to bond always the single electrons of one atom with the single electrons of another atom. That's what I'm always first going to do and see if it works. And this does work because now this oxygen has 1, 2, 3, 4, 5, 6, and now 7 and 8 electrons. The carbon has 1, 2, 3, 4, 5, 6, 7, and 8 electrons, and this oxygen has 2, 3, 4, 5, 6, 7, 8. So everyone is happy. This molecule is complete. There are 2 double bonds holding this molecule together. All right, good job. Let's look at number 3, SO3, sulfur trioxide. Now here I do have to consider, does the sulfur go in the middle or does one of the oxygens go in the middle? The sulfur goes in the middle, and a lot of students often say, well, that's because there's only one sulfur. No, it's because sulfur has the lower electronegativity value. And so atoms with lower values are always going to go in the middle. So I'm going to start by drawing S sulfur. It has 6 valence electrons because it's in group 16. And now I'm going to consider the 3 O's. I know that the 3 O's have to bond to the sulfur, so I'm just going to put the 3 O's all around the S's for now. I know they have to bond in some way, so I'll figure that out. Let me just first put the oxygens all around the sulfur. All right, so here I'm going to do this and this out of instinct. And now I'm going to ask myself, what is wrong here? You're right. This oxygen only has 7 electrons now. 1, 2, 3, 4, 5, 6, 7. And so does this one. And this one is like just hanging off. It's not even bonded. We totally ignored this oxygen atom. We're so mean. So instead, we're going to take away one of these single bonds. You might already be telling me, Miss Kiely, just do a coordinate bond. And you're absolutely right. We're going to do a coordinate bond over here. Okay, because this means that we bonded. We're holding this guy's hand here. We're like, okay, I guess we like you. And now this oxygen is bonded to this sulfur. It has 1, 2, 3, 4, 5, 6, 7, 8. So now it's bonded. This one is semi-bonded, it's not complete, and this one we've just left alone entirely. So let's consider again what we can do. We can make a double bond. Okay, we made a double bond, and now this oxygen has all 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. The sulfur also has 1, 2, 3, 4, 5, 6, 7, 8. So now we've left this oxygen hanging. But what you might notice is there's a lone pair up here. So let's put the oxygen up there and do what with it? You're right, let's share using a coordinate bond. Perfect, now everyone has 8 electrons, everyone is happy. SO3 is held together by 1 double bond and 2 coordinate bonds. Voila! All right, moving on to SO4 2 minus. SO4 2 minus, do you remember what that is? It is indeed sulfate. Sulfate. So SO4 2 minus is sulfate. That means we have to add 2 electrons in somewhere. Let's start with S, which we already know goes in the middle. It's in group 16. We're going to put 6 electrons, okay? One here. And let's put the 4 oxygens all around this S, because the oxygens, remember, there's a rule. Oxygens will never bond to each other. They will only bond to the central atom unless they have to bond to each other, like in O2 or O3, for example. All right, so I'm going to go like this, like that. And then I'm going to go, okay, well, here we go. Coordinate to this one, coordinate to this one. So the only atoms that are happy are sulfur, oxygen, and oxygen here. This sulfur has 1, 2, 3, 4, 5, 6, 7, and 8. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And same thing here. 1, 2, 3, 4, 5, 6, 7, 8. These do not. They only have 7. However, remember, this is a polyatomic ion, so we're going to draw brackets, put a 2 minus, and we're going to add in the electron wherever it's needed. So 1 here and 1 there. That means we have 1, 2, 3, 4, 5, 6, 7, 8 now. 1, 2, 3, 4, 5, 6, 7, 8. And so we have built this molecule with 2 coordinate bonds and 2 single bonds. There is another way, though, of building this molecule. So if you did it this way, you did it correctly, and maybe you did it a different way and you still got it correct. So I'm going to show you the opposite way. The opposite way would be to put the 2 electrons in the sulfur. So here's sulfur normally with 6 electrons, and now I'm already going to add those 2 in. So I'm already going to put into the molecule the 2 electrons that are added in the compound. And what I'll do instead is for every oxygen, I'm just going to make a coordinate bond. Since every oxygen needs 2 electrons, it makes sense to give it a coordinate bond because it gives it the 2 electrons that it needs. So that's one. Here's another one. Which means this would be 4 coordinate bonds. Okay, 4 coordinate bonds. Now, in the last one, what we said was 2 single bonds and 2 coordinate bonds. That's kind of the same as saying 4 coordinate bonds because coordinate bonds are just like single bonds. What do I mean by that? What I mean is a single bond contains 2 electrons, right? A pair of electrons. And what do these contain? A pair. Between this atom and this one atom, what's being shared are 2 electrons. Same thing as a single bond. So either of these is correct. All right, the same thing goes for our next one here, which is called PO3 minus phosphite. Very good. Okay. Phosphite. So number 5 is phosphite. I'm going to immediately put the answers for the 2 different types that you could have drawn, okay? You could have done phosphite by adding electrons into the oxygens, or you could have added the electrons to the phosphorus. So here I'll go 1, 2, 3 single bonds, and then I'm going to add the 3 electrons. I'm going to choose a different color. I'm going to put one here, and one here. And now everyone is happy, and that means that I made PO3 minus using 3 single bonds. Whoa, I don't know how that, what just happened here? Here we go. I don't know how that happened. Here we go. 3 single bonds. Every oxygen has 8 electrons because each oxygen gained one of these electrons. Let's do it the other way. The other way would be I already add those 3 electrons to my P atom, which starts with 5, but now I put the 3 here. And you guessed it, what I can do now instead is just make 3 coordinate bonds. Good job. So now, oh my God. So now I'm going to go O, 1, 2, 3, 4, 5, 6. Coordinate bond. O, 1, 2, 3, 4, 5, 6. Oh, that looks like a poop, right? Coordinate bond and coordinate bond to my last O. And now this one is the coordinate bonds. So either of these answers would be correct. Either of them would be fine. 3 single bonds is the same as 3 coordinate bonds because we're sharing 2 electrons. We're just sharing them differently. In this case, the O and the P are sharing them equally. One shares one, the other shares the other. In this one, it's just the P sharing. The P is able to share a lone pair in the direction of the oxygen. Good job, guys. NO2 minus, we're almost done. NO2 minus. Now, NO2 minus is not phosphite. What is it called? NO2 minus. Is it nitrate or nitrite? It is nitrite. Nitrate is NO3 minus. Nitrite is NO2 minus. All right then. NO2 minus. Another one that can have two ways of being solved. Let's start with the first way. N is in group 15, so 5 valence electrons. I'm going to do the other one over here. Now in this one, I'm going to choose to add the electron to one of the oxygens, okay? So here's oxygen. And here I'm going to put another oxygen. Now I'm going to go like this, and like this, and like this. So what is missing? Yep, the electron. I have to add an electron in. I'm going to add it right here so that this oxygen can be happy. So I have one double bond and one single. Over here in the other one, 1, 2, 3, 4, 5, 6. I'm going to add the electron here to N. And now the other oxygen, 1, 2, 3, 4, 5, 6. And so what I'm going to do is a double bond here and, you guessed it, a coordinate over here. And then brackets, because otherwise it's wrong. You do have to put brackets. And now I have one double and one coordinate bond. Again, same thing. So either of these would be correct. Now for the last two, these are kind of new. I didn't expect you to know them right away, so I will not be taking off points for those of you that might have done the last ones incorrectly. In these cases, the reason they're a little confusing and a little different is they contain more than one central atom. So let's look at C2H6. The C's have to both go in the middle because the H's cannot be in the middle. So what I'm going to do is draw C with its 4 valence electrons and another C. I'm going to bond them at least once here because I know all the atoms have to be bonded to each other. Now H6, I see there's 1, 2, 3, 4, 5, 6 available electrons there, so I guess that's where my H's are going to go. And indeed, that is where they are. So that means I have 1, 2, 3, 4, 5, 6 single bonds between C and H, and one single bond here between C and C. So I have 7 single bonds. 1, 2, 3, 4, 5, 6, 7. For the last one, N2H2, again, the N's have to go in the middle because H's have to go on the side. So I'm going to do my best by just drawing one N with 5 valence electrons and the other N. And everything has to bond to each other, so I'm just going to bond it here. And I need 2 hydrogens, so let's say I'm going to mess up. What if I put them here? What's wrong with that? Yeah, now like there's nothing for this atom to bond to, so that must be wrong. Maybe I'll put one H here and one H here, right? And I'll go like that and like that. Now what? The N's are not at their complete octets, but they can be if I just do this. So what I have here is 2 single bonds, those are between the H and the N's, and 1 double bond. Woo! Check these out. See how you feel with these answers. Email me if you have any questions. And make sure you double check the main page of Google Classroom for your next assignment, which will be due on Friday. Have a great day, guys. Thank you so much for participating.